A man at point A on the shore of a circular lake of radius 1 mile to reach point B on the shore diametrically opposite A. So let's say this is our circular lake. This is point A, and diametrically opposite that is point B. If he can row about 3 miles per hour and jog 6 miles per hour, at what angle with the diameter should he row in order to reach B in the shortest possible time? So from A, let's say we want to reach point B. So there will be a section where we will be rowing, and there will be a section that where we will be jogging. So let's say from point A, we will be rowing from this point up to this point. Let's say that is C. And we want to find this one, that. So this one is the distance that we will row. And from point C to point B is the distance that we will jog. And we want to minimize the time. So time will be the time spent in rowing plus the time spent in jogging. And we all know that velocity is distance over time. So time is distance over velocity. So this is the distance in rowing over velocity of rowing plus distance of jogging over velocity of jogging. So our radius is 1, so diameter is 2. So if we draw this one, we'll be having a right triangle since the opposite side is the diameter, meaning this one is a right angle. So using Pythagorean relationship here, the cosine of our theta is the distance we row over the diameter, which is 1 plus 1, and that is 2. So the distance we rowed, that will be 2 cosine of theta. And for the distance we jog, let's say we use this central angle. So we have this theta. Using the theorem here, this is twice of our theta. And the distance we jog is an arc length, and arc length is r theta. So the distance we jog, that is d sub j. Radius is equivalent to 1, and theta is twice of our angle. So using this formula, the time in rowing, the distance r, or 2 cosine theta, over velocity of rowing, and that is 3. Plus distance in jogging, that's 2 theta, over the velocity of jogging, that is 6. And let's say we get the derivative here. So this will be equivalent to t prime is 2/3 and the negative sign of theta, plus 2 over 6 derivative of theta with respect to theta, that will be equivalent to 1. And to get the minimum time, our first derivative should be 0. Shift solve, theta here should be 30 degrees. So to find our time, this will be equivalent to cosine of 30 degrees over plus 2 over 6, our theta is 30 degrees. We should make it radians, so pi over 180. So answer here will be equivalent to 0.7519 hours. So we make it minutes. 1 hour is 60 minutes. So the final answer here will be 45.11 minutes. What is the limit of 1 plus 1 over x raised to x as x approaches infinity. So you put this in your calculator, press calc, and when you are asked for the value of x, put infinity or a very large number, let's say 99999. So the answer here will approach a value of 2.718281828, or that is equivalent to E. The height in feet at any time t in seconds of a projection thrown is h of t is equal to negative 16t squared plus 256t. What is the velocity when you reach the ground? So the velocity is the first derivative. And that will be negative 32t plus 256. And that is our velocity. And we want to know the velocity when it reached the ground. So that is when our height is 0. Using a quadratic equation, so it could be either 0 or 16. So let's use 16 because t at 0 is our initial point. So when it reached the ground, it is after 16 seconds, that will be negative 32 times 16 plus 256. So answer here is negative 256 feet per second. A boy 1.2 meters tall is walking directly away from a lamppost at the rate of 0.9 meter per second. If the lamp is 6 meters above the ground, find the rate at which the shadow is connected. So let's say we have this lamp and we have this boy, and if there's a light, there will be a shadow. So let's say this is the shadow, and the boy is 1.2 meters tall, and the lamp is 6 meters. So let's say the distance of the boy from the lamp is x, and the boy is walking directly away from the lamp, meaning the x increases. At what rate? So that is 0.9 meters per second. Using similarities for our two similar triangle, base is to height of the smaller triangle is equal to the base is to height of the bigger triangle. So solve, so cross multiply, that will be 6s is equal to 1.2s plus 1.2. 6 minus 1.2, that is 4.8s. And then dividing both sides by 4.8, so s will be 1/4 of s. Getting the derivative of both sides with respect to time, this will be ds dt is 1/4 of dx dt. And dx dt is 0.9 meters per second. So what is our final answer? This is 0.225 meters per second. Determine the first derivative with respect to x, the function for square root of. So take note, the derivative of any constant is 0. A spherical balloon is inflated at the rate of 30 cubic feet per minute. At the instant when the radius is 15 feet, at what rate is the surface area increasing? So area of a sphere is 4 pi r squared. Let's get the derivative with respect to time. So that will be derivative of area with respect to time is 8 pi r dr dt. Then there's a given 30 cubic feet per meter, that is the rate of change of volume. So the volume of sphere is 4/3 pi r cubed. let's say we get the derivative with respect to time. So the rate of change of volume with respect to time is 4 pi r squared dr dt. Let's get the ratio of the two expressions. Derivative of area with respect to time over derivative of volume with respect to time, or the rate of change of volume, that is 30 cubic feet per minute. That will be 8 over 4 is 2. We can cancel out pi. We can cancel out one of the radius, and that will be 2 over the radius, and that is 15. And we can cancel out the rate of change of radius. So what is our answer here? The rate of change of area with respect to time will be 4 square feet per minute. What is the area under the curve y is equal to x cubed plus 3x squared, and the x-axis when x equals 1 and x equals 3? Take note, x-axis is also y equals 0. So to find the area without drawing the figure, that will be the integral of the absolute value of length, which is y up minus y down. Y up will be x cubed plus 3x squared, and y down will be our 0 from 1 to 3. Answer will be 46 square units. A triangle has variable sides x, y, z subject to the constraint such that the perimeter P is fixed to 18 cm. What's the maximum possible area of the triangle? So for a triangle with sides x, y, and z, the perimeter is x plus y plus z, and that should be equivalent to 18. Now take note, to maximize the area, it should be a regular polygon, meaning all of its sides must be congruent. So x and y is also equivalent to x, and z is also equivalent to x. So 3x equals 18, so x will be 6. So that's also the value of y, that's also the value of z. So meaning that is an equilateral triangle, which is also an equiangular, where each vertices is a 60-degree angle. So the area of a triangle with given two sides and a unit angle are 1/2 AB sine of theta. That's 1/2. A and B are the two sides, so the two sides are all 6. That will be 6 times 6. And the angle between them is 60 degrees. So what is our answer? So that will be 15.59 square centimeters. Find the shortest distance from 10, 7 to the circle. X squared plus y squared minus 4x minus 2y minus 20 equals 0. So let's say we have this circle, and let's say we have a point outside our circle. The shortest distance will be this one, wherein it is part of a line segment connecting our center to that point. We all know from this point up to this point, this is what we call the distance between 2 points. And this one up to this one, that is our radius. So meaning our shortest distance here will be d minus r. So we need to find the distance between the 2 points and the radius of our circle. So to find the radius, let's perform the completing the square. X squared minus 4x plus y squared minus 2y equals positive 20. Negative 4 divided by 2 is negative 2 squared, that's positive 4. Negative 2 divided by 2, that's negative 1 squared, that's positive 1. Since we added 4 and 1 on the left side, we should also add 4 and 1 on the right side. And this will become x minus 2 squared plus y minus 1 squared is equal to 25 or 5 squared. Meaning the center is 2, 1 and the radius is 5. We already have our radius. And to find the distance between 2 points, that's the square root of the change in x squared plus the change in y squared. So this will be square root of change in x, that will be 10 minus 2 squared plus change in y, that will be 7 minus 1 squared. So the distance is 10 units. So our shortest distance will be d minus r, and that will be 10 minus 5 or 5 units. Two posts are 8 meters and the other are 12 meters high, 15 meters apart. If the posts are supported by cable running from the top of the first post to a stake on the ground and then back to the top of our second post, find the distance from the lower post to the stake to use the minimum amount of wire. So the lower post is 8 meters high and the higher post is 12 meters high, and they are 15 meters apart. So meaning if this is x, so the other one is 15 times x. Take note, to minimize this hypotenuse, the two triangles must be similar to each other, meaning the base is to height of the smaller triangle is equivalent to the base is to height of the larger triangle. Shift solve, x is equivalent to 6.